It's this Coffee Compiler Club, and we're here today to talk about compilers and language runtimes and typing systems and anything and everything to do with, I don't know, garbage collection and cross-thread, multi-atomic, reference counting bits and the like. You're being recorded. You'll be up on YouTube within a couple hours. Open mic, say what you want. And, that's it. Let's roll. So I was gonna start with, did we have anybody else we wanted to, if I can figure out how to make Discord channels work? Here's the final one on somebody else to invite, because it was a fun one for getting Gilad here. Does anyone else have a not
so
that
the
one.
confusing thing with Discord is that invites are first channel specific, and then second they have a expiration time by default. It's like explicitly flagged that to never expire.
Oh, you can flag it to never expire.
Yeah.
Okay, I'll have to find that then. Yeah, that'll help. I've switched that Discord invite like 5 times now. And okay, fine. That's
yeah. So if you hover over the channel and like click the create invite button, you get like the pop-up, and then like in very small text it says your link expires in 7 days. Edit invite link.
Fine.
And there you can set the expiration time.
Thank you. Got it now. I'll have to make yet another one for next week. No, whatever. I'm going to skip next week. Fine. Yeah.
Really
so, sorry, Darrick.
It looks really cold where Simon is.
Very cold. Yes. You're no sound from you, Simon. You're not muted, but you got no sound. No sound. It's like your mic's not plugged in.
Test.
Yeah, say again.
Test.
Yes, there you go. That works.
I just caught a cold or something a few days ago. And...
Fuck.
Yeah, today is probably the worst day to get sick because all my colleagues are on the company Christmas party, except me, because
I make a mean hot toddy if you're,
I'm not that sick anymore, but I think running around with a running nose, like 150 other people.
The company parties, like,
idea.
Hey, everyone gets sick too. Fine. Yes, you gotta skip. Sucks.
But yeah, it got really cold here. I think -5 or -6 degrees Celsius.
Yeah, Cameron's off skiing somewhere in Vermont or New Hampshire. I mean, I don't know how cold it is, but he showed me a picture of snow everywhere. So
yeah, we also have some snow, but I think not enough for skiing.
Okay, fine. No,
so here in the Netherlands you can go ice skating now. In fact, so I moved into a new house and we have like a canal like right in front.
Mm-hmm.
And for most of earlier this week, the ice was not thick enough. So kids kept, because there's a school on the other side, kids kept kicking their balls onto the ice. So at some point there were like 5 balls and they couldn't reach it. I don't know, kids apparently don't realize if you have a rake and a rope, you can harpoon it, but whatever. But now it's thick enough, so now all the kids are on the ice. And it's actually dangerous to go outside because there's ice everywhere, and they do put salt on the road, but not on the footpath.
Yes.
And so I had to ditch 5,000 kilograms of cardboard boxes. And doing that, carrying them like on the back of a bike on ice, it's quite dangerous. Slipped almost a couple of times, basically.
Wow. No. We done our move in the spring, not in the winter. And now we're just living with it's moderately cold. Did I tell you about the dead deer? I cleaned the dead deer out.
Oh, no.
No.
Living in the mountains is different problems.
At least Christmas dinner is a sort of problem now, right?
Yeah, well, we spotted it when it was Christmas dinner for the vultures. So it was already well along by the time we found it.
What's life like in the California mountains anyway?
Oh, it's actually really nice. We have an amazing view, like broadly accepted by all the neighbors as well. It's just unbelievable. I would say 90% of the days we have 40-mile visibility out over the ocean, and to Monterey Bay, and Santa Cruz and Capitola are clearly visible. We've had firemen up on our deck looking for fires they can't find because we have such the view. It's really nice. And the house is, I don't know if I told you this, I sold my Sunnyvale house like it had gone, the market had skyrocketed in Sunnyvale, because Sunnyvale is 5 minutes from Apple and 5 minutes from Google and 5 minutes from LinkedIn, 5 minutes from 101 and 280 and 5 minutes from everywhere. It's centrally located every fucking thing on the planet. Home prices skyrocketed. I sold a shoebox in Sunnyvale for basically a mansion, or a substantial, what do you call it, large house. Like Europe may call it a schloss or something. And I have giant windows overlooking huge mountain ranges. Within 10-minute walk from my house, I can be next to a tree that's 1,000 years old, and it's probably 200 feet tall. It's a good 20 or 30 feet at the base. Maybe I'll throw you guys a picture. I could throw you a picture.
And this was a straight up trade, basically,
straight
for
up
the
trade.
small house in the city.
Straight up trade. Yep.
That's amazing.
Yep. Exactly. And the house has well water and goes up to a septic and tank, which means I take water from the mountain, I put it back on the mountain, so I'm not actually taking off of the aquifers or anything else. And I'm solar paneled to the nth degree. Whole house generator for when PG&E drops the power, which they have done like 5 times since I moved in. But the generator kicks in 10 seconds, and I've got everything else on battery backup, so like you hardly notice. There's a lawnmower running outside your house for a little while, and then PG&E sorts it out and it goes away. It's fine. The only issue now is it's like 10 minutes to get to the Summit stores, the nearest small grocery store. It's actually pretty decent. And then it's 15 to get to a freeway, and basically, 20 to get to the smallest podunk town, and 30 to get to any reasonable town, and then 40 to get you everywhere in the Bay Area. So there's no
how far to the
short
nearest
trips.
pub? That's the question.
I'm sorry?
How far to the nearest pub? That's the question.
Oh, no, it's not close. Wineries are actually, there's a bunch of wineries within any wine tasting within the 10 to 15 minute range.
Oh.
Nano's is a Italian pizza place that serves beer. Closest thing as a pubs you get. After that, yeah, now you're into like 20 to 25, and then you start getting some choices. So you make your plans when you go grocery shopping and stuff. You don't. You're not going to go out and get a gallon of milk and come back.
The minutes you mentioned, is this by foot or by?
Oh, this is by car. Oh, this is by car. The trails. I'm on the very top, not quite. I mean, on the ridge line, very top. But from here, if I take the 2 trails near my house, in half an hour, I'll drop 1,000 feet, and then turn around and have to walk back up 1,000 feet. So exercise is walk down the trail till you think you've had enough, and you turn around and it's twice as much going back. No, you're not gonna. I've seen people. No one takes a bike on the road here. The road to and from, like the main road where the little Summit store, the tiny store is actually kind of decent. The road up to where my house is hasn't been paved in forever and badly needs it. I would not be enjoyable on a bike. I see occasionally people on a bike. It's not a good bike route. So walking on the trails is good. There's a lot of folks do that. Not many bikes. And then, like I said, it's like 10, 15 minute drive to get somewhere, anywhere, 20 to 25 to get something more impressive. Like I need a hardware store because, the deer knocked a hole in my deer fence and I need to go repair that. That's 30 minutes.
Yeah. I grew up in the countryside and everything was like that. You had to shop. You generally shop for a week kind of thing. It's not like being in the city where you
and you go
spend
run all your
5
errands
minutes and get your groceries for today.
New and improved since I was a kid is that the folks will deliver everything to your house. So for modest delivery charges, UPS, FedEx, private delivery show up at your door all the time with stuff.
Is
Okay,
the
so we're like-
Summit Diner still a thing there?
I'm on Summit Road. There's Summit Store. It has a nice deli, but there is no diner up here in forever.
Okay, you'd know if you saw it, if it was still open.
Well, it depends on where you are, because if I go further, I go to Highway 17 and carry on down there, there's a couple of diners right near me on 17 that I haven't actually done yet. I should do. Some of them look fine. There's like two, and I could go check them out. And I think maybe one of them in the past might have been called Summit Diner, because it's right at the summit of the mountain ridge and near Summit Road. But that's a 15-minute drive.
Oh, okay. Yeah, it'd be hard to miss if it still had that name. So
No, I don't think it has. I remember one from many years ago, many years before I moved here, like 20 years ago. And there's a couple diners in the same spot, but different name. Yeah, that's fine. Well, okay, there you go. That's my, mountain living story. Whatever else things I got, instant heaters for the hot water, and it comes off the well. So, there's no price to having an endless hot shower. It doesn't run your water bill up. Gas consumption is very modest. Never mind. Okay, fine. Many other cool things about the house that I'm still getting used to. But that's a later thing. Let's do
Maybe
something.
talk about compilers. Yeah.
Oh, come on.
Oh,
Exactly.
Well,
exactly.
I'm working through basically porting over your AA forward flow lattice typing thing.
You poor man. Yes.
Well, I mean, I've got int types and the simple types ported. That was easy. It was like the code was nice and clean, and since I'm not doing the null stuff, it took out the biggest complexity.
Yes. A lot of it would go. Yeah.
But basically, I got to the point where I have the you have some tests that you do in the startup. You test that they're commutative, symmetric, and associativity. And I've got all of those passing. And then there's this other block, which is like test confirm symmetry or something.
Yep.
It doesn't pass for me. Like virtually everything fails. And when I look at it and try and trace it out on the lattice, to me, the test seems wrong. I just don't, or I don't understand it.
Okay.
So
Ken just joined. Let me flag him. And then okay, so the lattice is, I think, semi-distributive because it lets me reorder the order of operations. If you do a mixture of meets and joins in any order, and you want to get the same answer independent of what order you do a mixture of meets and joins, you have to be like semi-distributive. So that's what that guy's testing. So he does a little bit in the comments. Let me pull up the comments. I could probably even Google Docs this one because it's kind of it's a little non-intuitive, obviously.
Yeah, I was looking at what it does on the lattice, and it's just like I have a sort of drawing of the lattice, and I was tracing out what it does. Yeah. It's like it seems like the answer I get is correct, yet it's not what the test wants. So.
Right, so this is check symmetric?
No, it's the confirm symmetry.
Oh, symmetry, confirm symmetry. Yes, okay. Okay, yeah, right. So this is a useful thing to throw into the docs, which probably means to put the docs up. Let me go throw this in the docs and catch other people up to what we're talking about, because I think this is an interesting one. Somebody's doing code blocks for points. Here's the code for, okay, now we're going to try the new and improved Google. Somebody said there's a way to get code out straight up without having to go, well, I'm not seeing how you get code out. Paste code. Where the hell was looking at the damn Twitter notification. Here is somebody doing paste code. They right click, they're scrolling down, there's a code block. What? Where do that again, dude? There's a way to directly insert code into a Google block. So building blocks, I don't even know how to do that one. Okay, let me go back to Google Blocks. Google here. Here, format options, no. Okay, so whatever somebody's doing there, I ain't got it. So, you know, it's not doing it. I have this thing, this code extension. Yeah, color code. Okay, let me one more time here. Language, we're gonna go to Java.
You want to share your screen?
Oh, fuck yes, I do. I'm like too many complicated things. Okay, there it goes. Fine. Oh, that's pretty bad formatting. Oh, that's no worse than it was before. Let me hit the share.
Otherwise, I'm wondering whether
Yeah, right. Yeah, everyone's in the dark. No one knows what's
whether
going
the
on.
audience becomes really,
Yeah,
really
right.
good at imagining code in like a few years if we keep doing that.
Right. No, you're 100% correct. Right. Okay. So the indentation just completely failed. Let me see if I can undo. All right. So no color coding, but the indentation's a little more sane. Not really. Oh, he's got 4 space tabs instead of 2 space tabs, or I don't know what the hell he did for indentation here. He like really screwed it. Fine. All right. So the indentation screwed up on the paste. Fine. It's all spaces, by the way. There ain't no tabs. So I don't understand why he decided my spaces were tabs on the paste and then did weird tabby things. So the point of confirmed symmetry is this Boolean algebra at the top here. If A is a B, then A join C is a B join C. And is the same as A meet B is equal to B. So you can sit down and do Boolean algebra on it and discover that that's a tautology. It's like a useless statement, except that it kept finding bugs for me. Certainly it's finding something for you. So that's the issue. So A is a B triple equals to A dot meet of B is double equals to B. If I replace meet with the and sign and claim I'm doing algebra, I get like A and B is mathematically equal to B. And then join is the dual of everything back and forth. So join, so A join B, so I'll do the vertical bar for join is, and you know, tautology with twiddle A and twiddle B, find the A here, yes, okay, and the result twiddled, so that's the dual. So if I then take this statement that I have, A is a B, and I replace it with Boolean algebra here, I get A and B equals B is true. If this is true, so this is an implication, then
You know what? I think I have a wrong definition of is-a. I was doing this late at night last night.
okay. Well, is baked into the code.
Yeah. It's baked in the code. It's a one-liner. I didn't actually look it up. I was just thinking, oh, it's like it's a Java is a type thing. And now I realized
No. This is a Boolean algebra game here.
All right.
Something like that. You get some weird implication. If you go do a bunch of De Morgan's laws, it comes a tautology. There's nothing interesting. In practice, it finds bugs. So that's what it's doing.
Yeah, okay.
So if that's your problem, then yeah, fix your ISA and then, you know, go run again. But if you haven't, if it's just, this is probably the first time I do ISA in a test here. So the is this line right up in the for loop here. If T0 is a T1, then do things. Let me see if I can fix the indentation while we're talking. Because that was a horrible paste job for whoever did that. See, there's a tab. Funny tabbing games. You see how many tabs I got here. Yeah, there's a tab there. I don't understand because I don't do tabs ever. So no tabs. So somebody pasted, decided I had to have a tab and I didn't want to. Yeah, you got more tabs in there. Fine. Right, and then your friends are all screwed up. Okay, yeah, that's under here, right here. I don't get balanced paren matching, so I don't know. I don't have my closed parens correct because I don't have balanced paren matching in the editor. Fine. Yeah. So the comment is what the comment is. You can see I've expanded the second is the A join C is a B join C by computing the meet and claiming that they ought to be equal. And if they're not, you're going to get an error. But I have the meet in purpose because it shows up in the error message now. You get an error message. And so you take this little printout you get and you do a little space alignment in your editor and you line them up vertically and see that they should do math. And then you can say, oh, I blew this or that or whatever. One of the things got blown.
Yeah.
So
yeah,
this is
and I actually just replaced my erroneous type thing with ISA, and which I just wrote in. It's pretty easy. I still have errors, so I still have something wrong here.
Okay.
The errors look the same, in fact.
Okay.
Yeah. Let's see here. So
you could throw an error out if you want to, or we could just let it go and let you sort on it. This is all. This is like lattice theory, has like little to do with anything except you have to get it right in the lattice. If you get it right in the lattice, you can use a work list algorithm for an efficient incremental solution to the typing answer.
Yeah. So here I'll throw some code in the block here. So the test first.
Yeah.
And so that's the test. And then I've got a failure here, which I'll throw right underneath. So this is just telling me what all the variables are.
What's the unknown?
That's your all.
That's my what?
All.
Oh, okay. Okay. As opposed to uninitialized, which would be my any. Fine.
And I still use any, but then yeah, so I just do any and unknown. I don't know. I kept on getting confused between any and all, so I just made them more different.
Right. So the leading T, is that some sort of type indicator? Like T0 is a type of an int 8?
Yeah. Yes, that's right. It's just, yeah. So there's a macro that'll parse those. So it's an int 8 with an actual value of -1. Is an unknown.
It's a constant -1.
That's right.
Okay. As opposed to uint 8, it would be, it's not a size variable, it's constant -1. Okay.
Yeah, so I could have an int 32 -1 or an int 8 -1.
Oh, okay. That will probably get you flagged here in a minute. All by itself, because those are not canonical, and you end up with two flavors of -1. And if you want to allow them to be used indiscriminately between each other, somebody's going to complain about it because they're indiscriminately they have the same semantic meaning with two different shapes. It's not necessarily a thing you want to go to, but we'll do that in a second here. So what I see is you have a constant for T0 is a constant -1. Yeah. T1 is the bottom of the lattice, the all for me, unknown for you. That sounds great. T2 is an unknown unsigned int 8. So any old unsigned int 8, any old byte.
Yeah.
Okay. The meat of T0 and T2 says that you've dropped the unsigned and you've picked up a -1. So what you just said here is I have an unsigned value from 0 to 255. I meet it with a -1.
Mm-hmm.
And you have widened the unsigned to signed so you can pick up the -1. And the value that you've kept -1, but the original unsigned int 8 carried values from 0 to 255, and you have to actually keep them as well. So you have lost the fact that you have a value from 0 to 255. And what you should have done is widened yourself from -1 to 255.
I should have.
So the meat says take all of both sides. Every possible value you can have on either side has to be in the result.
Yeah.
So you have values from 0 to 255 on one side, value -1 on the other. The mix of the two means you have to have -1 to 255, which is not
Right. Yeah. So
representable.
I need actually
in
32 here.
Yeah, you have to you have to widen now.
Assigned in 30. Yeah, assigned in 32.
Yeah.
Oh. But yeah, okay.
So
But the funny thing is that
there's more
the
failure
expectation here, it's sort of wrong in both places.
Yes, because if you meet unknown with anything, the answer is always unknown. You have two sides of an if, you don't know which it goes. If random, you take the left, which is totally unknown. You take the right, which happens to be an unsigned byte. What do you get when you mix at the end? Well, you get a totally unknown and an unsigned byte. The answer is totally unknown. So that's 1, 2. T1, 2 should have been the full unknown, not an unsigned int unknown.
Yeah. Okay. I actually had there was a sort of tricky thing that I came across where, because I'm representing signedness, the byte values between 128 and 255 are byte when they're unsigned, but when they're signed, they're not. And so I guess it's kind of similar to, it's basically, you know, the range shifts over, right?
Well,
so
yeah,
I ended up creating two size, like byte size values in the type, an 8 or sorry, a signed and an unsigned version of the size. So like if I have you know, 200 as my constant, and it's, you know, it only works as signed byte, but so I would have for the, sorry, it only works as unsigned byte or as a signed in 32, right? So I have a z value, which is the size of 8, and then a zs for z signed of 32, both in the type. Does that make any sense? I'm not sure if I'm making any sense here. So that I can kind of switch between them, because I can lose the constant when I do a meet, but I want to try and keep those sizes, right? I don't know. I think maybe I've got something wrong there.
I was trying to figure out if it was time to, I mean, like the thing that I did in AA isn't friendly to unsigned versus signed unless you just widen yourself. I was looking at what I did at C2, which I just use low and high ranges, and then the widening math is much simpler, except that you have to have a simple in one way, more complicated in another. So I don't know if it was helpful or not.
Yeah, actually maybe I should change it to low and high ranges, and
right. Let me
so
show
basically
you
drop the bit count thing.
Let me show you let me show you the C2 code, which I've just drug up on the screen here. It's sort of stupidly trivial for the meat. So that I'm going to take the meat, I'm going to cut out the junk in the middle, which
I think we're only seeing your browser.
Yeah, I'm taking it from Emacs and throwing it into
okay.
code block here. Let me go call this this is the C2 int, meat operator. Okay, so in the middle, I'm going to ... There's all these broken cases to make life a little easier. So the meet operator basically says, well, the first line is shortcut, just meet same, get out. Second stanza, switch on the base being incorrect, you get a junk answer. It's like you go to unknown. You mixed an int and a pointer, you get an unknown, and it's going to be a type error, and somebody handed you broken byte codes, and it was sorted out from there. Otherwise, You take the min of the lows, you take the max of the highs, and then the subtle part is you have this widen operator, which you take the max on. And the trick with this one is, because of the precision of the in ranges, if you start a numeric for loop for I equals 1 to 1,000, he'll say I is the range 0 to 0 in the first iteration, but on the next iteration around, it's 0 to 1, and then it's 0 to 2, and then it's 0 to 3, and it takes you 1,000 times before you hit the limit of it. Right, and so you lose the property that you're bound. Your lattice is not bounded anymore, or it's bounded by the constant size of loops. So you have a widen operator that you run on every once per loop, which usually back edges. So my phi function, which does the meet, says meeting two guys where their widens are equal. You bump the widen one more time. As soon as the widen gets bigger, let me pull that code up too. As soon as the widen gets beyond the max widen value, which I set to 3, you get, so let me put this in. I'm gonna put it up above the meet operator because it's part of the setup elsewhere. So basically it says, if your widen operators aren't the same, you're going to bump to a larger widen. What I'm really doing here is I'm looking for prematurely widening I'm letting small ints keep their constants alive. Everyone else fails out to widen. When you've gone widen, your type gets hammered to min and max, integer min and max, and he quits trying. He basically says, I'm going to widen you from 0 to 0, 1. I'm going to widen you from 0, 1 to 0 through 2. 0 through 3, I give it up. It's now max int, min int to max int, whatever. Full in 64 case. And that's not obviously what's going on there, but that's what it's doing.
But when are you working step by step through a loop while you're doing type inference? Like, don't you just look at the loop bounds and do it there? Like, when are you?
Okay,
I
so
don't quite
right,
understand
so
when this would happen.
So AA's type inference is modeled off of C2's optimization, which is really computing a more precise type than I got out of Java bytecodes. Right, so C2 routinely for me produced sharper types than what the type system gave me. Often I was able to reverse generics as well, like detype erase generics, I could totally reverse them. Frequently, not every time. So when I was looking at this, I decided when I was doing AA that I was going to see if I could do typing this way. So AA is doing typing via the same technology that C2 is doing optimization on, basically, for doing value computations. That I have to be handed values at the start of the program because the forward flow starts from something and pushes it forward. But once I've handed something, like here's your incoming types from your signature of your method that you're compiling, you push it all the way through and he can tell you all kinds of things about the type ranges for ints and whatever. So it's not right there. The C2 version isn't trying to do typing. It's just trying to sharpen the value set. The AA version is actually trying to do typing. So I'm discovering the values that appear at a program point. That's its type.
Right.
So I might tell you that this value, this variable that you haven't given a name for the type, you've used the Java var, but if you get untyped, I'm doing type inference. Oh, it's an integer, it ranges from 0 to 1 million, or it's an int 16, or it's an unsigned 8, or whatever. I would deduce the type.
Yeah, and that's what I'm trying to do too, because I don't have any type annotations so far, and I was hoping to keep it that way. Yeah,
you can't do polymorphic type variables this way, but you can do everything you can do with like C style or Java style typing, which starts with the type annotation at the borders. And you don't need anything on the inside, but I need type annotations to start with.
With AA as well? No, you don't.
No, AA is using Hindley-Milner. She's using type variables, polymorphic type variables. Also, right. I tried for a long time at AA without polymorphic type variables, and I couldn't do it. And in hindsight, it was obvious why not. You know, I'm a slow, stupid guy. It takes me a while to get there. Fine. You actually have to have a bidirectional typing system to do full inference, which Hindley-Milner is, or you have to be handed something to start. You have to have an initial condition, and you can push the initial condition forwards. So
Yeah. So I'm hoping that because I don't really have many types at all, that I can sort of just pretty much assume everything's an int.
Yeah, I think you're,
It's just, is it a signed or unsigned int or whatever? And then, the things that are pointers or memory locations and whatnot, or not pointers, but functions, they're basically they're effectively typed because they have their own, specific byte, specific IR representation, and then they become specific nodes. So that's no problem. The only challenge that I have is, I mentioned in Discord about the PE types, and so you're right. It's basically, if something is on the PE array, it's kind of that fact poisons everything else that it touches, and that also must be on the PE array. I think that I'm pretty sure that'll work okay. But I think I have to propagate that in reverse as well. So like, I have a statement where I do some math, multiply something or whatever. I'm gonna then store it or do a PE operation on it. I need to basically push that backwards. But I was thinking that I just have a pass, that kind of work list style thing that just pushes that information up to neighbors without it
in
really doing
AA, I call it liveness info. And I'm
Uh-huh.
tracking liveness as well. And you have
Yeah.
a similar property. It's used by the PE array in the future. So
Yeah.
going backwards, I'm producing a value that's used by PE array.
Yeah.
Somewhere you have to do the juncture where I'm going to move it from the risk side to the PE side.
Yeah.
And don't you have the reverse as well, right?
What do
You
you
have
mean?
to take a result from the PE array back to the risk side.
Yeah, there's a pretty specific mechanism for that, and most of the time the results in the PE array actually just get DMA'd directly back to the host.
I'm saying in the semantics for the programming language, the type system, if you're going to talk about PE types, you have to have an operator which does the reverse. And it could be, in your case, that operator is explicit. You have to write the code. It's a special magic primitive that says, intrinsic, that says move results back into memory from PE memory to risk memory.
Yeah.
There's
So
a line in the sand, and you wrote some primitive operator, and it said, and now the PE puked results into the risk.
Yeah, exactly. So that operator where I'm reading from the PE array into a register in the risk.
Yeah.
It basically, the result of that is just not PE data.
Yeah, I'm just saying, right? Yeah, exactly. You have to have that operator. It has to exist, but it's easy. It just has to exist.
Yeah, exactly.
Yeah,
that's no problem, I think. And I can go the other direction as well. Data that is legitimately in the risk, and then I send it off, like I can broadcast it into the PE array and stuff like that.
Yeah. You need, right.
Yeah.
Since you're representing them in the lattice, you'll come to places where you cross that boundary and you'll have to decide left or right. And the backwards flow works just the same as the forwards flow. If you look in the AA code for the liveness stuff,
okay,
the field is under live. It's live and live use. So the two main guys are slightly different than the value use, but they're doing the same kind of thing.
Yeah. Your code in the test lattice in AA, that seems to cover the same stuff as what you ended up putting in your startup checks in just type.java, right?
Test lattice was a thing I did to make my lattices simpler and more explicit so that I could reason about them.
Yeah.
And then I came up with a set of properties I wanted, and then I enforced them in that code as well. And because I'd been enforcing them for a while in the main code base in AA, and then having trouble getting a lattice that met all the properties I wanted. So then I did this test lattice guy, and he's just here's how you describe a lattice as simple as possible. And then does it have the properties you're looking for? And if not, here's exactly, it's constructive failure. It gives you exactly the point where you fail.
Yeah. Yeah.
So if you're fooling with a lattice, like you want to say, what if I do this PE thing? You can go add a test case there and
Yeah.
get told shortly that it's wrong or right or something.
Right. Yeah. At some point I may try and get the AA test suite running and just start using that tool directly. I really want to try and build that myself.
Yeah, that one is standalone. That file is entirely standalone.
Oh, okay.
If you just pull that up in a Java, IntelliJ, and you say I'm Java, and you go pick that file up, it's just a test case. You just run a test case in IntelliJ,
Yeah.
a JUnit test case.
Okay. Yeah, I might do that.
Has no dependencies on anything.
I was very surprised when my PE stuff and my science stuff generally passed the first set of tests. Because I basically wrote I started reading your code the night before last, and then I ported the whole thing yesterday. And yeah,
Excellent.
except for missing the ISA, went fairly well.
Yeah. Okay. Good. I claim it was all fairly straightforward stuff, but your mileage may vary.
No, it's so
Fine.
far it's good, but I think I definitely went a little bit of a wrong turn with the bit size stuff, so I think I might go to ranges. Doesn't the ranges also give you a nice property of being able to do kind of arbitrary ranges, which then you can use for dead code, and you can stuff.
So exactly, you have a low field and you have a high field, and the widen is so that you can get bounded running times.
Yeah,
and that's like it. So it's 64-bit integer, so I can't do unsigned 64-bit, but I can do signed and unsigned versions of everything below 64 bits and signed 64 bits.
Yeah.
It's the 1A was an experiment. I don't claim it was wildly successful. It was a little wonky looking. I'm not terribly happy with it. I'll probably go back to the range version.
Mm-hmm. Yeah. Okay. Well, that's good.
Yeah.
It's anyway, even when it's doesn't work, it's kind of like always good to take a different perspective. I don't know, learn it from a different angle. So
okay. Are we ready to change topics here? Is that what I'm hearing?
I think so.
Somebody wrote class color point. Is anyone
yes. This is my code. It's an example from this paper. It's called like inheritance is not subtyping, and so I've been trying to just work out the example. I mean, the paper is like unreadable. It's just this mess of like garbage, and I don't know.
So explain to me what your backslash means.
Oh, that's just set difference. So it's like the point set minus the color point set. So I'm saying the points that are not color points.
So if you're doing an equals check, like question, should these be definable? You're equals checking color points and plain points. Yes. Should I allow that to be defined where I forget the color on the color point and just compare points?
Right.
Gotcha. Right. And then you have this symmetric other case. This is where Cameron checks in and says he defines equality as the same and requires it to be that. So if you attempt to compare a color point and a point, Ecstasy will say type error that these two are not comparable. Fix your bug. Right? This no, you don't get to find. So Cameron answers no. That's a better way to put it. Cameron says no, you cannot define those.
Also, I mean, you can also just define them to be false.
Yeah, right. Yes.
And so so that's like another way of looking at it is you say, oh, well, they're both, records, and like this one has a color field that's a real value, and the point has a value that's not set to anything, so it's not equal. So
yes,
but they have to be symmetric. So if you ask the point if it's equal to the color point, you just give the same answer when you ask the color point if it's equal to the point.
Right. So the Java answer here is he does not enforce symmetry, and you can totally write broken equals. Cameron says that's broken. I'm going to enforce the two types be actually the same, and you get a type error if they're not. And Alan's question, I'm just restating it again, is basically if they're unequal, but one's a subclass of the other, should we allow you to define it on the subportions? Should we allow you to define it on the as a false? It's always fail because points are never color points, even if the points and the color point totally align. Or is it a user definable property where some people say I want them to be equal and some people say I don't? I don't know.
Yeah, because like, I mean, you know, if you have like two random types, you might want to define an equal method between.
Yeah. If they're subtypes, you define an equals
Well,
method.
no.
they are.
I mean, so that's actually the point of this paper is it argues that color point should not be a subtype of point, because if you apply a point method like move, it will not give you a color point back, so it'll be the wrong type. So in fact,
in Hindley-Milner land, this would be called row polymorphism, or the lack of row polymorphism.
Yeah.
Yeah, and C++ deals with this as well. They say things like, you want to move a thing that you know to be of type point in the compiler, but at runtime it happens to be a subtype of color point. You call a virtual move effectively, which does a constructor and produces a color point and does something for the missing color value.
Yeah, this is not going to be a problem in C++, to be honest. I don't see the point of this example. And when you write this method, if you were to write this method point, you wouldn't write this as a method, first of all. You would write this exactly as it is written as a freestanding function, but you would take it by reference. You take the reference to point, and the color point is a reference to point, so it just passes through, and then you return the reference to point, and you modify the X field, and you modify the Y field, and you leave the color alone, and nothing but happens, and you do not need to write another move function like the one written below, so it's not going to be a problem at all. I don't see how this example applies.
Because it's changing the values in place.
Yeah.
And,
Yeah, that's fine.
Yeah, he's doing a, yes, this is a side affecting operator.
May not be fine.
I'm creating a new value, and so that's where the
But if you are creating a point value, then that's your exact intent. So you want to create a point with the move coordinate X and move coordinate Y. Why should it have a color then?
Yeah, right.
You are writing a factory function for a point. That's a factory function for a point. It looks fine to me.
Yeah,
So
I agree with Matt. In the end, that most object-oriented or imperative languages make it easier to mutate the instance compared to creating a new instance. Shouldn't be an argument in favor or against some technique.
I want to clarify here. If I'm making a new instance, there's the version of that making which says make a point, and I name the type, and it's obvious I'm making the point. There's another version that says make a new instance from an old instance. This is a copy collector or a copy constructor, and the old instance is a color point or not, but I happen at compile time to only know it to be a point. Does the constructor, a copy constructor, make a full color point from the thing that it's given? I guess the answer is the copy constructor totally can. He just mem copies all the fields. And you get that's row polymorphism kind of. I mean, you get a color point back, even if the compile time only knows it to be a point or below. That's a copy constructor in C++ I'm talking about specifically.
You may have to write a clone function or clone method because the fields may differ. Maybe you have a color point, maybe you have a rectangular point, say, which is going to have
the copy
different...
constructor would do like clone in Java. It would bulk copy the fields irregardless. So yes, I'm claiming, yes, you have to have a clone, which the copy constructor in C++, as far as I know, is like a clone.
And it will give you a new instance of the point here, for example, for the desired subtype class or supertype.
It gives you, shit, it's been too long. I prefer the clone notion just because.
Yeah, by default, point is going to point copy constructor would just slice it.
Yeah.
It would only preserve value X and value Y.
Yeah.
But that's kind of, I mean, that's only fair, right? Because you could have infinite number of subclasses of that. So there is no possible way it could know what are the other fields. You would need to have some kind of virtual method like clone.
Yeah.
You
so
can
right.
clone, I mean, you can write your own copy constructor that's gonna call clone, but that's on your own.
I thought the copy constructor at C++ did the virtual clone. He
Not by
asked the length.
default. By default, it's going to be just the value.
Okay.
And
fine.
and the points copy constructor is only going to see the points values because it cannot see any other values.
All right. So there's your answer, Alan.
So I have a different, well, I mean, the take on this was that you, like in the Java way of doing equality, if you ask the subtype, well, what point would do, I don't know if you did it here, but point would make an equals method that checks that the thing passed to it, which is an object, is a point, and if so, then it checks its X and Y.
Yes.
But if that's a color point, it has no idea because that was written by someone a year later.
Right.
Else. So it just cares about pointness, but color point might want to be equal to point or might not. But
this is a left and right symmetry question then.
Yes.
If I do point dot equals color point and color point dot equals point, what I'm hearing you say is they can give different answer.
Well, no, they can't if they want to be valid equality. So what you can do if your class like point is not final is have a different method that you basically delegate to the subclass. Say, can you equal me? Because then the subclass writer gets to decide. Okay. And if that's false, then it's false. Otherwise, it's true. You compare X and Y. And
so there's a stylistic way to write equals in Java that preserves the notion that equals is symmetric.
It's symmetric and it allows subtypes to sometimes equal the supertype and sometimes not. So it depends on, it's sort of a way to do it. And the equals methods are hard enough to implement anyway. And this would be like you have another method in Scala, we call it can equal.
Yes, you have to go look at the equals method I have in the AA types, C2 types, because I have to handle structural recursion with cycles.
Yeah.
So it's not trivial.
Yeah.
To write the equals.
But what sounds like Cameron did is he just outlawed it.
Yeah.
Subtypes can't equal supertypes, which to me seems a little.
So when you call equals, the trick with that is that when you call equals, you need an extra argument. You need the left-hand side and the right-hand side, and the type of the left-hand side as an actual runtime thing, because he has to compare that to the type of the right-hand side to blow you out or not.
You mean Cameron?
Yeah, Cameron. Yeah. He had to do a thing there. Like,
yeah.
If I pass equals as a lambda expression into a map call, I'm taking two arrays or collections, and I'm walking the collections in order, asking are the two members equal, right? And then one is a collection of points and one is a collection of color points. He has to, whichever way who calls what has to decide that I'm always doing point comparisons or I'm always doing color point comparisons. And if I'm doing color point comparisons and a point shows up, I have to say, no, you're not equal. Or I have to say, I think he says compile time error. Then he's not here. He's off skiing, damn it.
Yeah, that's fine.
Cameron, where are you when we're
there's one
talking
answer
about
is subtypes can't equal supertypes, but another answer, it just doesn't work that subtypes can always equal supertypes. So this is a way to.
Yes.
But,
all right, have we beaten equals to death yet? Cameron, not Cameron. Alan, did you get your question answered?
I mean, I got some thoughts. I mean, I think it ends up being user definable because, like, I think you have to be able to decide like whether you want equals or not for your color point.
Yeah, but then it comes down to while you're making it user definable, is it also the case that you can no longer enforce symmetry, that you require the user to boilerplate symmetry or not?
Well, I mean, that's where I got you, because like I carefully wrote it in like multi-method dispatch style. So like the way I wrote it, you can write, the symmetric style and it all works out fine. So all
right, fair enough.
Nobody complained about that. So
yeah. And I guess if you have two unrelated subclasses, they should always be unequal. If you have two sibling subclasses, they should just fail.
Well, like, I mean, what if you're defining different types of nodes and you want to be able to compare all the nodes to each other? So,
for instance.
Yes.
I usually declare siblings in the node hierarchy is not equal.
Yeah.
So in another sibling case would be Java's number class, which has integer and double subclasses. Would you declare an int and a double ever equals? Well, suppose the number is 1 or 0 or something, the 2 to the 57 or less, then it has an exact representation in both.
Yeah, yeah. Well, I mean, that's where you get, it turns out you want multiple equals. You want like a semantic equals, and you want a, you know, are these actually the same value in the representation?
I have a very odd version of that in the AA code, which is when I'm done with interning, pointer equality is semantic equality is true equality. Before I'm done interning, I have to declare these two large cyclic structures the same. And I have to go into hash tables, which require me to use dot equals. So my dot equals does the complicated recursive walk with cycle definition tests. And when it's done, I never use dot equals again because I only use it doing interning in hash tables. I guess it's pretty normal, I guess. I don't know. My semantic equals is equi-recursive.
Yeah,
But
and
I
then
have
got
a
like
equals that tests
JavaScript equals, which is like, well, convert strings to numbers for you when you're comparing.
Yeah, right, exactly. Is
Which,
quote 3 quote equal to 3 the integer? Well, JavaScript says yes, and I'm like, no. Fine.
yeah, and then so like I don't know. I mean, I've concluded you need at least like you need at least 2 types of equality and maybe 3 or 4 if you're being really
Right.
pedantic.
And so I think it's fair to say I'm going to hand you a dot equals. By hash tables will use a dot equals with a dot hash. And after that, you're user defining your own equals. And if you want to user define equals on a hash table, you can go write one.
So containers need like an equality that actually compares like the values of things, and then like you for like within types you want they define their own notion of equality within the type, and so that's the 2 that I have, and then like
What's the second one? What's the difference with the second? Well, how is that different from the one the collections want?
well, because like for example, if you have IEEE numbers, for example, if you compare 2 nans, you'll get, I think it's false because they're
Right. That's the spec.
Yeah, that's the spec, and so like that's
so you wanted of course, yeah, you want that's the equal. Okay, that's
yeah.
easy.
So
Yeah,
like,
actually,
obviously, if you have a container and you have nans, you want the nans.
You want it to be
value equivalent. Yes.
ordered. Yeah, you want it to be an order.
And in fact, certainly at H2O, we had that same exact problem.
I see what you mean.
You're throwing a bunch of numbers in a hash table for keys. One of them's a nan.
So that's, by the way, you were complaining about Scala's merging the 2 and auto boxing. So that's one of the things it had to decide was which equals. Like in the way Java did that is the primitive int is, adheres to the IEEE spec, but the boxed integer does not, so that you have an order. And so when you sort a collection of integers, they actually make sense. They don't, there's a, it sorts right. So now if you're going to merge them together, it's like, which one do you use? I think they picked the wrong one, or I can't remember now. They had to pick the right one, I guess. The one that sorts.
Like the latest IEEE standard defines this like total order predicate, which is, I mean, it actually is a real comparison operator in that it's, transitive and reflexive and so on. But
it just says not a number is never equal to anything. I think that's how originally, I think there was an email that said that the reason they did that is the hardware didn't have a way to test if something's not a number or not. So the way you told is compared it with itself, and if it was unequal, then that meant it was not a number. And then we're stuck with it forever.
Here's is that in the links now? Yes, it's in the links. Here, I'll go.
Oh, that's funny. Yeah,
don't direct me to
even
the
use point and color point.
Oh, with Darrick as well. I see.
Yeah. Well, he figured out the delegation idea, which I thought was solve the problem. But Josh Block complained that this violates Liskov, which I don't think it does, but anyway. That's a different question.
Yeah.
Oh, well, but yeah,
like-
I mean, as far as inheritance, I've concluded that the best thing to do is just leave it as untyped and like not have a type system that's completely separate from inheritance and not do anything.
Weren't
Just-
you last week saying that inheritance, you just shouldn't have it at all?
Yeah, no, then I
Oh, you're
realized
right.
like people use it
So-
all the time in dynamic languages.
Oh,
So like,
okay.
it's really convenient. You just like say A inherits from B and then
Mhm.
like, so it's like an extends operator with a fixed point. So
He even posted on Reddit.
yeah.
Well, I had a, if somebody wants to, another topic, it has to do with subtyping, kind of. It has to do with lifetimes. I've been trying to figure out what lifetimes
Go,
are.
go.
Huh?
Go ahead.
Yeah, so the Rust documentation talks a little bit about variance, and it makes sense that, like, imagine you do have inheritance, and you have a supertype and a subtype and a method that returns something that's going to live for us. In the superclass, the method returns something that's going to live for a second, and anybody who calls that is not going to use it after a second of time. And if somebody overrides that in a subclass and returns something that lives 2 seconds, that's going to be okay, right? That will not. Basically, the person who's using it at the more abstract superclass type.
The second, it will outlive the first one.
Well, the caller will not use it after a second, because what he knows is he's got the superclass signature. It's in the lifetime that's returned at
Hi, Kevin.
1 second. So it won't use it after that. So if someone overrides that and there's a subclass that actually has longer,
That's fine.
that's okay. That's covariant return type. So that means that the lattice, and I think it's a lattice, has things get bigger as you go down. So the subtype, remember, 1 second is the super type and 2 seconds is the subtype.
So the point being to encapsulate the longest type, someone it will use it. It will always fine, because it's for you. If you want to use it for a second, it doesn't matter how much longer does someone use it.
Right. So that's what basically, if you now imagine the lattice, you go all the way up, the top type is never like a lifetime of 0. If you go all the way down, the bottom type is always and forever. It's like infinite time, from the beginning of time to the end of time. I mean,
I would say, okay, the order doesn't matter. What is top, what is bottom. I would switch it around, but this doesn't matter.
Well, it sounds upside down, but that's like subtype, supertype. If it's like that, and it's like sub lifetime, super lifetime. So the other way is contravariant parameter type. So like if something eats, let's say that something, there's a method, like a superclass that has a method that actually takes a parameter, and that parameter is going to live for I'm going to say 2 seconds. And so I take that as a parameter. I'm going to pass in, oh geez, now I'm going to be confused. I'm going to confuse myself. This is contravariance, but it's basically the opposite. It's like,
yeah,
I'm going to feed it things that
have to live at least 2 seconds.
Is that right? Yeah, because it takes something that lives 2 seconds. I have to.
So the super type is the thing that it outlives all its subtypes.
No, the other way around.
Well, yeah. So actually, my question is, what is a lifetime? Basically, there's a lattice, and if you, I actually I'm very tired, but I thought I was going to be able to explain the contravariant one, but it actually works. In other words, if you pass something in that eats things that last a second, then that person's going to pass things in that last at least a second. It could be a subtype, which is longer. That's fine, because that thing eats things that last a second. So the contravariant parameter type is that if you override that in a subclass, he could actually take something that lasts less time, and that's because then if someone's using it from that API, they're gonna pass in things that oh god, I lost it again. I'm sorry.
So
no problem,
I'll put it in Discord. I actually had it like
an
an hour ago, but it
Yeah,
does
hold-
work.
But yeah, pull the written example up. It's probably easier to look at.
Yeah, I will. I'll post it in Discord, but it does work. I had thought that through. But what I guess is confusing is like there's a lattice here, and for example, that that example they give on the Rust documentation about a lifetime annotation where you have two strings, one that's living longer and one that's shorter, and of course they say which string has the most characters, and then you have to it won't type or lifetime check or whatever they call it unless you put an annotation there and say both of these are it's like a abstract type or the abstract lifetime. You tick mark A.
A tick, I believe.
Tick mark A, and you say both of these are A, and they're going to find the least upper bound, which is going up the hierarchy, and that is like the union type between those two types, which makes it smaller because if you're going up, it's going to be smaller. So it's the shorter of the one. So the result type is the shorter of the one. Because no matter which one of those they pick as having the most characters, if you are not going to use it after the shorter one's lifetime, in case it's the shorter one's lifetime, that's fine. If it's the longer one's lifetime, then it's also fine.
But
that's basically
my view is that this is from the view from when you can deallocate or can you reuse the string which leaves smaller than the larger string.
You guys have you're talking about a fixed example. Is there like a link somewhere?
No, this was just like in my jogging. Oh, you mean the longer one? Yeah, I can get a link for that. Hang on a second. Oh.
I think the core idea is that whether we are looking at inheritance or subtyping or lifetimes, they share concepts which we can describe through the lens of variance, for instance, or we could also describe them through the lens of Liskov.
That's the Bill's point is, can you model a lifetime as a hierarchy of subtyping? And it likely checks out to me.
I think so. I mean, it depends on what exactly, what kind of inheritance or subtyping model you have in mind.
Yeah.
But
well, I'll have a link here. But my question is, what are the nodes of this lattice? Is it actually time?
Yeah, hand me the lattice picture.
Okay, let me. Well, lattice picture was in my head while I'm jogging. I mean, these are the things I think about. But
yes, okay, fine.
Where is the doc? Hang on, I'll paste it.
Paste in the chat. I will paste in the doc.
Oh, okay, I found the doc. My first time pasting something in the doc. Oh, I put it.
There's a link section.
Yeah, that's the lifetime annotation. So look for. Let me see what. There's a bunch of stuff on this page, but the annotation example is called lifetime annotations and functions. Can I link just right to this? Oh, I can. Hang on. Let me get how do I get the link? Copy link. Okay, I have a better link.
Oh, you have a better link.
Yeah, goes right to it. It's on that page, but
okay.
There it is. That one.
Just floated in now.
Yeah.
It hasn't made itself a link yet. I'm gonna take the.
Oh.
I'll get it.
Okay, thanks. That's the signature. So this is what I thought. And the other thing about the other thought I had, of course, this is ugly. I'm sorry, but I mean it's like verbose. It's like tick mark A, and what they're really computing is the least upper bound. And so if you had union type syntax, really it's like X, the lifetime of X or the lifetime of Y would be the lifetime of the result.
But the tick signifies
naming these lifetimes like this.
But this implies the concept of a lifetime with the tick.
Yeah, well, the tick mark
is really concerning. It is concerning the types, but it's not really concerning the type properties, but the liveness of the type, as I get it.
Yeah, they merged it like they have ampersand tick mark A str. That's like all one big bundle of like type. And usually they infer the lifetimes. I don't know about usually. I haven't really used this, but they try to as much as they can.
I saw this. This is like one of my goals for AA is to figure out some nicer way to do lifetime management typing constraints or checks or something. Whether it's inferring or not, I don't know.
But anyway, what I don't. Like, we all talk about lifetimes. It kind of makes sense to us in terms of time, but is it like, it's kind of weird because I think they're like, I guess you could think of it as a points on a single line, and that is time going back into the past and into the future, maybe going from now into the future.
In the land of
What
single
are these
threaded
things?
programming, you pretend that you're some kind of CPU, you execute instructions one at a time, sequentially in order. There's definitely a time notion. Give a total order on all events. Given that total order, lifetime makes sense. You have a beginning and an end of the lifetime.
Right.
That's just the mark on the unrolled infinite CPU execution trace.
Yep.
I think at the most abstract level, it makes sense to look at this and look at generics and look at inheritance as a model of constraints, and these constraints have different rule sets on determining overlap or subsumption or equality, or how they can be divided or combined with each other, and everything, and the details are simply domain specific. So how you combine these constraints differs in the lifetime domain from the generics domain, or from the inheritance domain, for instance. And maybe there is some unifying language with which we can describe these constraints, where the generics and the lifetimes and subtyping are just instances of that language, so we can more easily compare them. I think this would be interesting, but yeah, not sure something like this exists.
Yeah.
The other thing I don't know, so like if you have union type at the lifetime at the above you, least upper bound, what's your greatest lower bound? Does anybody ever use that?
Well, you run to the end of the program with the lifetime.
Huh?
You could run the lifetime to the end of the program.
Yeah.
X and Y are static strings. They're put in the binary as permanent parts of the linker's load set or whatever.
Yeah, they call that static in Rust.
Yeah.
It's like, it could be like sort of always and forevermore. That's could be the bottom type.
That's exactly what I'm saying. That's the always in permanence. It's the lifetime of the process.
Yeah, so, I'm really wondering whether the lifetimes have similar issues with their bottom type than one usually has with their bottom type in generics.
I believe they don't, because the top type or the bottom type, no matter, is I use it for infinity or I don't use it at all. And as long as the lifetime is capped between these points, the lattice, as Bill says, comes naturally, because you can always pick 2 points and say what is the subsumption point that outlives the other one, and that's, you form the operation of the lattice.
Yeah, I mean, the question I have is, what's exactly what constraints, what rule do we have for lifetimes that prevents it from having the issues that generics have? Is it just that we're not allowing to parameterize?
My hunch is that the nothingness of the bottom type is that it's really cannot represent any value. But here is just a lifetime. You can pick, I use it all the time or I never use it. And as long as it's between two, the types has a different notion of the top and bottom. The bottom type have to have no values, and it has a slightly different notion, because you cannot have a type that is a value that is a bottom type. But as the lifetime,
what issues are you talking about, Simon?
For instance, making open. I think there was at least one interesting paper on soundness issues, where you basically have this nothing type in the type system, and you're building impossible bounds. So you're basically building things where you say, okay, this is a subtype of bottom and also a super type of these other things, and do wild bounds magic. And then because it's still a Java, you have null, and null is a valid value of literally everything. You end up having an actual value of this bottom type, and then things all explode. Or for instance, the issue Scala had for a long time, that you could do things like array of nothing of size 5 and then pull things out of arrays that shouldn't actually have a value, but the JVM says if you have an array of size 5, you have to have like an array with 5 thingies there, and you can pull out these thingies. And and I think there are a few more examples. I think
okay, that as long as there's no null lifetime, then you won't have the null one. But that null one was that's a soundness hole in Java's.
What you try to demonstrate is to collapse the hierarchy, to basically the top type becomes a subtype of nothing types, and hierarchy collapses, or the other way around. Which is it?
What's weird about this is like it seems upside down, like the thing that has no inhabitants is on top, and the thing that has everything's on the bottom. It's like it's not a lifetime. It's almost like it should be lack of lifetime, the opposite of lifetime, whatever that is. And then
it was one thing I learned about playing these Lattice games is everyone interested in the dual, and they all have it in their heads that they flip left, up and down, and top and bottom, and they get confused in themselves. And when they're talking to other people about which way they're talking, who's longer, who's shorter, who's high, who's low.
As long as you determine the properties of what you want, you can call it what you want. It's the top.
Yes. And I do my property testing, and then I don't fucking care what you want to call it or I want to call it. It matches the property in question.
Yeah, that's fine.
And then the math just works.
In my book, that's fine.
How's this for an example of I was trying to think about the contravariant example. If you want to reclaim a piece of memory, you can take something that has a shorter lifetime, and it's like that's acceptable in that case. Like you might think I'll reclaim something that's a second old, but this one's only a half second old. So that might be a case where the shorter lifetime is substitutable.
Yes. I'm going to reuse a piece of memory. The guy who's using it has a shorter lifetime than
My hunch would be that the lifetime would ask the question, how much big of a memory I can pick up so all of the users can fit this lifetime, so I can know when to deallocate it. And at least I understand it as such. So between two strings, if you want, you always pick the larger string. The smaller string can fit in this memory, and you can efficiently deallocate it at the end of the operation.
So the other thing I'm hearing here is that Hindley-Milner, the experiment I did last week with Cameron on Hindley-Milner and contravariance was that I could mimic, or Hindley-Milner will let me derive correctly typed things. It would say ignoring code and contravariance. He would infer the proper code and contravariance for me. And he would just tell you what the correctness, it would be correct or not. And if it was not, he would say how it was code or contravariance, but you had interesting typing come out of the inference. It was not necessarily what people typically think about, but it was clearly always correct. And he had it's just the standard, he inferred it for you. And if you misused, you got told where and how is obvious. But he didn't have classic co-contravariance annotations per se. So I could pull that example out again.
Yeah, I want to actually talk to you about that, but I just think I thought of it. So let's go back to my superclass subclass. If I have a method that eats strings that last I hope I just had it. Let's say it eats strings that last a second, and I override that. I can override that and eat strings that last I'm going to go up. So I'm going to be shorter, eat strings that last 1 second. So the superclass eats strings that last, it takes a parameter that those strings last 2 seconds, and this one takes a parameter that lasts 1 second down here. So if I'm using it from the abstract type, I'm going to pass in things that last 2 seconds. But if I'm actually using the subtype, he's only going to use it for 1 second max. Maybe that's what you were saying down there. Actually, I don't know, but that's like sound. In other words, I can be unaware of the subclass. He's just not going to feed me anything that lasts longer than a second, but I'm going to like be prepared for it to last a second. So that's the contravariant parameter type. So it's actually, you know, a lattice, I think. And then there's a union type, which is what that longest string thing is. That what they're really figuring out is the least upper bound between those two lifetimes on the lattice.
Yeah.
And that's the shorter one, because as you go up, it gets shorter. So anyway, what's weird, I like, it makes sense with a single thread that it's actually time, but if it's multi-threaded, you know, like, and one of the cores is moving away at near the speed of light.
Yeah, the multi-threaded
doesn't seem like it's time necessarily.
So the standard guarantee you get from the OS is that you can be preempted at any clock cycle for any length of time. So it's not that one thread is moving away at the speed of light, it's that all other threads are halted instantly and make no progress at all, while the other guy runs at normal speed, however long he wants to. And then he's halted and somebody else makes progress. So you can arrange, you know, the adversarial OS can arrange any particular interleaving.
Yeah, which it makes it weird because so the other thing it could be is like space. If you look at your code, it's like this spot, like maybe you compile into some form where from here to here, that's a lifetime or a segment, not in time, but in some kind of space in your program.
How long will you use this allocated space or this?
How long are you using this thing in your code? Not
I believe this is the concept to represent the lifetime.
Right. Well, you can mix how long I'm using it in the code with time in a single thread environment straight up. Those are equivalent. Unless you're hard real time in your setup, you can't do that. Hey, see you, Dan. You can't do that in multi-threaded. But that's the whole happens before thing, is trying to come up with a way to define semantics. You can do analysis on the lifetimes that are allowed. If I know my lifetime went from here to here and it happens before you here and happens after you there or whatever, then I can say something about, you know, your lifetime is bounded by mine or mine is bounded by yours or whatever.
Okay. Well, that helps. It's just like what's confusing me. I'm just not sure what they were. I mean, the lattice kind of makes sense to me, but I don't know what what is each node. I'm not sure what it is. You know, I think it's more like kind of a program. Like, what is a lifetime? It's really, I think, more of in some representation of your program. It's like between here and here in the program, probably not in really.
If you unroll the execution of the program in a straight line that runs forever, and you declare that a lattice, it's a trivial lattice that's just this straight line of program points that the CPU is executing one after another.
Okay, and
that's what those nodes are in that lattice.
Okay, yeah, that's true. Even if you have multi-cores and they're kind of doing all things at the same time, you could still sort of like put points on the.
Yeah, so if you have multi-cores and you do sort of a not a total store order thing, then you have to have multiple train tracks that are parallel running, all going forwards linearly. But periodically there's a jump from one to the next, or it happens before relationship. And I can say this happens before that.
That's very interesting. All right, that'll give me something to think about my next jog.
And then
that was my
And then the evil hack. So that's the model that most programming languages go for. That there is a serializable order. There exists a serializable order for all CPU operations across all threads. This is not strictly true because it's truly parallel in the hardware. There can be operations the CPUs do that have no serializable order. And that's some programming CPUs, multi-core CPUs allow these behaviors. This is a case where you have all these little, what do they call it, flavor, the test cases, basically tiny test cases. I start with memory of R0 and R1 as being both 0, and CPU 1 loads, tests that it's 0, and then stores a 1 in the other guy, and the other guy does the reverse. So they both want to load, check that they're 0, put a 1 in the other guy. And so your theory here is that, in the end, one of the guys sees a 0, puts a 1, the other guy only sees a 1, doesn't change anything. And the end result is one of the values is 0 and one of the values is 1, and one CPU got stalled because whatever. But due to the race conditions, they both can read a 0. They can both set a 1 on the other guy, and it is allowed to have an operation where with the results both 1s. And that particular example seems pretty obvious, but they have a bunch of them they go through, and you can get these sort of weird ass A happened before B and also B happened before A at the same time, unless you've used the hardware correctly using the various memory model. Like if you don't put fencing in the right places, you can totally have it's must be the case that A happened before B and also B happened before A. That kind of conflict can totally arise on most chips. I'm not sure about x86. I shouldn't say most. I'm fairly certain ARM would do that. I know Azul would do it. I know Itanium would do it.
Say that again. The situation is
okay. So there's some games. I don't have the damn things that they have a funny name for them in the land of what is the hardware memory model, but they're basically tiny test cases. And a sample test case would be, I read one thing and I see a value, so then I go modify it or another guy, something. And the other thread is doing sort of the inverse. And you would like to claim that there was an order where I read and you wrote and I wrote, but there's a serialized order between them all. Okay, so you can come up with examples where things could only happen if there was no serialized order. If I did something and litmus test, thank you, Matt. Litmus test was the name I was looking for. And it's up there in the chats, probably in the links already. I'll hit the chat button here. This kind of weird ass thing, yes, where some guy wants to write a value, read a value, and the other guy wants to write a value and read a value, and can they cross over each other in this example test case where there's a complete cycle that happens before relationship. And these happen in real life on real hardware unless you put fences in the right places. And this guy has put one fence in, but not a fence on the other side, so he probably has this race condition here.
Okay, I'll check that out, because I thought time might not work.
In multi-threaded, time does not work unless you go to the next step of saying, I have a model I want to mimic. So it's actually the hardware does what the fuck the hardware does. So that's time is completely wacko for hardware. Okay, because he's physics. You want to have a software model. What software model would you like? A nice one is there exists a serialized order, even if it's hard for me to figure it out. Okay, to have there exists a serialized order, I probably have to constrain the hardware's behavior. As soon as I constrain the hardware's behavior on a multi-core system, if I do it poorly, I can really hammer my speed because CPUs run much faster within themselves than they can talk across to each other. So I don't want to have every time I read and write a memory that I have to stop and talk to all other processors, or I'll slow myself down to the speed of every operation. I have no cache. Effectively, I have no cache if we do that. So to have a cache, I immediately have a problem that the two guys run past each other. And then they have this impossible things. And so to fix that, I throw fences in and have a discussion about things. So I won't go through this here now, but I totally get that here's a whole bunch more of them where people are trying to show I have, cycles, and are they allowed by this processor? If I throw in, are they allowed by the Java memory model? Are they allowed by the C memory model? Are they allowed by the processor? Are they allowed by this rev of x86 and not that rev? I mean, I lived in the era, I coded Hotspot in the era where the cross-processor communication was dictated by the motherboard, which was dictated by a third party. If you had a compact motherboard versus a Dell motherboard, your multi-threaded race conditions varied. Intel did not have any control over how threads talk to each other across the motherboard. And that meant that, Hotspot was trying to just then become multi-threaded concurrent. It was trying to do parallelism for real for the first time. And we ran into all these things, which eventually led to a very long path down to come up with a Java memory model, which led to many, many PhDs and a whole lot of other shit. And eventually Intel took over all the motherboards. And then they could come up with their hardware memory model. And then there was a straightforward mapping from the Intel memory model to the Java memory model. And that made everyone else get on board, and they all came up with, well, here's our memory model, and to make the Java one or make something similar, you can do this. But yeah, in the standard thing, as soon as you go multi-core, you do not have a serialized timestamp order, and lifetimes become different, which is like why Pony exists as a language. It's a study on what can we do to define, people have seen Pony. Pony Lang. It's got to be Pony Lang. There you go. Fine. I'll throw the link in. Fine. Anyhow, yeah. So in the land of multi-threaded and memory sharing, you need to do something more than Rust does. More than what Rust does. Look at this other link from, should you throw that one in the docs as well, Matt? Litmus test and step through it. That would be fun.
It's pretty cool. It actually has memory models for multiple architectures, ARM, RISC-V, PowerPC, and also x86 TSO is in progress. It's pretty impressive.
Yeah. I'm going to move Pony after that one because it goes with your other one. There. Yep. I'll have to play with that. That would be fun. I did all this stuff back in the day for Hotspot, and wow. It was a crazier time.
If you load this RMM, I can tell you how to start an example since it's on the screen anyway.
Yeah.
So on the very top, load Litmus.
Yeah, hang on. I have to go. Yeah, okay. Load Litmus. Yeah.
And then say from library. And let's say, yeah, try maybe ARM v8. Because PowerPC, it's probably the one least people are familiar with. So on top.
On top, I say
on top, a bit more. Higher.
I don't.
Higher up.
Oh,
yeah.
Geez.
Yes, it's easy to miss. And say store barrier, for example. Store barrier example is SB.
Okay.
Yeah. It's actually, I missed that too. And now you can see that you have the state, which is the left window on top.
Yes.
You're going to have the graph of the instructions with the happens before relations and so on. And on the right, you actually see the actual assembly code. And you see that there is the two pieces executed in parallel. You have P0 on the left and P1 on the right. And you're trying to see whether there exists a state such that X2 register is going to be equal to 0 on the 0th thread and on the first thread. And you have the initial state X1 equal to X, X1 equal to Y, X3 equal to Y, X3 equal to X.
Okay, wait. The initial state here is okay. For X1 and the capital X1s are like
registers in ARM.
Oh, registers in ARM. And
remember,
X and Y are
capital X is 64-bit, but W is 32-bit, so it's a little bit like RAX and EAX in x86. We could have done with x86 too, for that matter. But so for example, when you're gonna see that register W0 is initialized with immediate 1, then you are also writing to register X0 implicitly because it's just a 32-bit part of that same register.
Then you load from some address of X into register 0.
Exactly. And then you
store. I'm sorry, this is a store.
Yes, you store the value in W0, which is immediate 1, to the memory location. Gotcha. And the address of that memory location is in register X1.
Okay.
And then you load from the memory location where the address is in register X3 to register W2. And that's all done in the processor 0.
Yes.
And on the right, you are simultaneously trying to write the immediate 1 to register W0. Then you are storing this one also to memory location X1. And then you are loading from memory location X3. And notice that the memory locations are swapped because you will see that register X1 denotes memory address X for P0. and register
Oh, I
X,
see. So,
X3 denotes
so
Y.
processor 0 has some address of memory for X is 1. Okay, so this guy is storing a 1 into the memory variable X.
That's
Processor
the
0
same
storing
that the other one is loading from the.
and the other guy is loading from Y, and then he's storing
Loading.
oh, he's loading. He's storing a 1.
Storing to Y and loading from location X.
So both of them are storing a 1 into. Oh no, I see. One storing a 1 into location 1, one storing a 1 into location. I'm sorry, one storing 1 into location for X, one storing a 1 into location for Y.
Exactly. And then we are going to see if it's possible that they didn't see those stores. So is it possible that we are going to end up with the states so that what we load, and notice that we always load to register X2, which is the same as loading to 32-bit part W2. Is it possible that we're gonna load zeros from both memory locations at the end? So we wouldn't, is it possible that those stores are not going to be observed?
Yes, and the answer, of course, is yes, because it's a store barrier example without any fencing. So the answer is yes, they would not. It is possible. Okay.
And you can basically step through this. You can also do the exhaustive search on random search. You can even keep stepping execution state. So on top, try clicking next.
Where I'm looking for next. So.
The same bar as load Litmus, precisely. Now you are going to see a start the interpreter. You are on the thread that's going to be fetching the instruction, and you can see which instruction you are fetching.
Move 1 into W0. Okay. What do I see? Which processor? This I hear is like processor 0. Okay, there's some processor number in there. Boy, fetch next. Am I actually making progress here? I'm not doing something. No, he's being slow about something.
Hold on, I have to restart on my side.
The console on the left is showing steps. A lot of my nexts aren't doing things here. Here's a change. Yeah, fine. I'll stop, but there's an obvious. Oh, he's doing like slow forward progress on instruction fetch because it was not in cache or something.
If you just want to step forward, click in your mouse. You see this graph on the right. Click, for example, on one init fetch instruction. You can choose the next action to do. Yeah, for example.
Okay.
Yeah, exactly. And you can also select these actions. You are basically stepping through the execution states forward.
Right. Okay.
And notice that now we are exploring just a possible execution path, but in concurrency, there's many interleavings. So we can also, of course, do the search. And search is from the top window as well. You can search exhaustively or randomly. I would try for small examples, it shouldn't matter, but for bigger random is usually on the safe. Exactly, because exactly of the warning, you can see it can be a lot of states. Okay. Although for this time, we should be able to explore this without issues.
Yeah, okay. I'm going to stop here.
And you have a big tutorial on the bottom left window.
Right. And so, here is some amount of discussion about what it's doing for the.
Yeah, it's like at a micro operation level.
Yeah, basically. Right. I get it. Interesting.
Yeah, it's pretty cool because it's much easier to see this laid out for you than reasoning manually.
Yes, right. And then, what do you get for an answer can you get the failed answer? And the answer is, I'm sure you can here. Some amount of storing on things will eventually do. Yeah, one of my older projects, actually pre-Azul, for Azul, was doing a simulator for the upcoming Azul hardware, which you didn't have yet, on an x86 because you didn't have hardware. In the simulator, you got to simulate shit like, I have a store buffer, or not. Or I'm using the x86 as store buffer, or not, or whatever. And one of the fun ways to detect race conditions was act as if I had a maximally sized store buffer and all stores were delayed as long as possible until you had a fence and had to force them out. And then did you have a collision with somebody else who's reading from those locations at the same time? And if you did, you probably had an error. me and Steve Goldman were going back and forth on finding the next race bug in the hotspot VM. He was on an Itanium at Sun, and I was at Azul doing a simulator, and we were once a week popping up a new race bug we were handing back and forth on. With a lot of that was a fun time.
By the way, if you finish this, you can also see that do you see this console when you have currently step 41?
Yep.
Yeah, if you scroll up just a little bit on that windows, scroll up. Yeah, you see here, it tells you that it was able to reach state where the final register R2 is going to have value 1, and the other one, processor 1, is going to have value 1, and it's going to list all the sequence of choices that correspond to the execution path that led to this. Right. So if you do the exhaustive search, for this example, it's actually fine. It's also going to find the state where you can click OK. It's also going to find the state when it's 0, 0.
Okay, did it update the console here?
Yeah, one of them should be 0, 0.
Oh, go find it here.
That's 1, 0. That's 1, 1, I think. That's 0, 1. That's 0, 0. Yeah, and then if you click on this ones, on this underlined sequence, then it actually shows you that execution path, and you can also, I think, step through that one.
Step through the path?
Yeah.
Where is the step through? But that's fine. I get it. I mean, there's going to be a store buffer somewhere in his micro-op state, and he's going to pin all those writes until the answer's done. Thread state 1, micro-op, load immediate if mem is load and mem-op is store, else prefit.
You basically have to keep clicking on the yellow. You see this yellow interpreter tool. It highlights those choices that correspond to the execution paths for you. So we can basically keep stepping through these choices like that, for example.
Oh, I see.
And I think next and back also do this for you, as long as you're on that path.
Yeah, I'd have to study the thing a little more to figure out. Okay, he's marching along somewhere in there.
Because there's a lot of tools. So
right.
It's not super fast, but it's
interesting. Okay, no, that's fine. All right. I'm going to claim this is slow going and I need to stare at it more, so it's probably a bad plan to do it at live the whole time here.
Yep.
Yeah. All right. Anyone, anything else? I'm going to call it quits here in a minute.
Yeah, well, I went back. Someone posted and they called it Bill's article. It was like how to write an equality method in Java.
Yeah.
I don't know if it was, but thank you, because it pointed out. So like the original example I had of like making color point forget the color, it turns out it's not transitive. So like it's not an equality method. So.
Oh, interesting.
Yeah.
Because like A equals color point of A equals normal point, or color point. Oh, color equals point equals color would lose the colorness in the middle.
Yeah.
And you would not be transitive. Oh, okay, fine.
Yeah. So I mean, I don't know. I mean, it still doesn't. I'm not sure it really addresses the problem because, like, was the problem to write an equality method, or was the problem to write like a method that compared things in the way you wanted? And I don't know, but like
the main comparison in Java is object, because the object has the equality. If you can produce this hash code, and
I mean, it worked. Like multi-methods were designed for this. Like the whole point of multiple dispatch is that you can write an equality method on like two different objects, and and then you don't have to worry about it being asymmetric or it being defined in one class and not the other, or any of that stuff.
Right. We need to haul Cameron in and like see what his solution is. What was the other one you talked about, Bill, doing a somebody did this, a subclass equals, like you asked if one was a subclass of the other, and then if it is, you reverse the arguments and throw it equals again. Right, there was a
You mean me?
Somebody was saying that you can delegate to the.
No, that's, you don't
subclass.
ask if it's a subclass. You ask like in Java, you get an object.
Yeah.
And you say, is it a point? If I'm class point, I say, is this a point? And then I would compare X and Y. But if I'm not final, that means someone may subclass me.
Right.
Then I need to be symmetrical with what my subclass says. And if you want to let the subclass decide if he can be equal or not to me, like if he doesn't override equals, he might as well be equal to me.
Yeah.
Then I could just say, can you equal me? You ask him, are we equalable?
Yeah.
Can we be equal
You
to each
reverse the
other? And he
arguments
says,
and-
yeah, why not? I mean, I have the same equals method as you. Then I'll just go on, we'll check X and Y. But if he decides that, he's a subclass, but color matters.
Yeah. Right.
So then he's going to have three things in his equality method. He would return false from, well, you're just a point, so you can't. I basically what my can't equal method when I override equals would just say, are you an instance of colored point? And if that true or false, that's what you would answer.
Yeah, and
you override equals, you override can't equal, and just return.
Right. Okay.
Yeah, that instance of colored point. So it's algorithmic.
Yeah, right. But there's a
the
stylistic notion that gets you back to being, I want to say, transitive.
Yeah, I think that the core contribution of this can equal thing is that it makes it more descriptive in showing the choice of the subclass, whether it allows being compared to the superclass or whether it disallows it.
Yeah.
Otherwise, it's like inline somewhere and hard to see. And
Oh, I see what you're saying. Like color point here says no, points are not colored, but it's kind of mixed around in things. Like if I have a point here and this one is fine, and I have a color point and I'm Java, and so I do this, except I ask, are you a color point? No, false. Yes, do my thing, but I want to pass up to the points to the supers or something. Yeah, it's certainly hard to read as to what you intend here. I have this kind of issue in spades in the AA code base right now.
In Bill's article, he overrides the equals and allows the argument to be an object, and always test if the compared object can be casted to the object you are comparing to. And
right.
Our other examples are false.
Or yeah.
Mm.
If you're that's semantically equivalent to the version that says you have to be the same subclass.
Mm-hmm.
You might have a shared common class. You always have object as a shared common class. You might have some shared common prefix, but you demand the left-hand side and the right-hand side be the same class, not a subclass thereof. And then you get all the questions of the subclasses don't care, so I'm going to say that it's they have the same equals or not. If color points don't care points from color points, or points don't care color points from points, points can say, you're a point, I'm a point, we're a point together, I'll do an equality check. If I'm asking about color points might say, I ain't no point, because points ain't got no color. But I might want to call point to get the super class parts tested, but then I'm going to also compare for colors.
Yeah, that's I read. He also has an end test super equals that. That means the superclass test also.
Yeah, I do a lot of super dot equals.
I think the problem with that one is
I'm carefully boilerplating the left-hand and right-hand side games here.
The one you just described, Cliff, I think that's not symmetric. If point only cares about pointness, if you say X equals Y,
yeah,
and X is a point and Y is a color point, he'll say true, because it's 1, 2, 2. If you do Y equals X, he's going to care about the color and he'll say false.
No, you're right. It's not transitive. I'm thinking of where the intuition goes wrong. Like, is it possible for me to define a point which doesn't care about his children? If I do so, then I have this non-transitive behavior where color point equal point equal color point, or not equal, whatever, dot equals point is not transitive. Yeah, it blows the transitive properties.
The point of extends is to introduce new information, and how can you, if all can be down upcasted to points, then now it's fine. But if you go the other way around, every other stuff can be mixed with every other stuff. How can you even define equal?
Yeah, I was looking at the code there. I of course have this same problem with hash codes, because I have to do hash codes that reflect what your equality says.
One thought I have is that wouldn't we have this issue if we didn't have inheritance? Probably not. And the second question that is like the weaker version of that is, would we still have the issue if we didn't have untyped equality methods? And I think that's an interesting question, because if you didn't have untyped equality methods, then you could say, okay, you have like an equals method on point that requires that you put in a point, or have a color point that equality method that requires a color point. And if your two instances don't match up, well, you have to convert one or the other to make the types match up. And I wonder, that would be more explicit. Are there any drawbacks to going?
You have to define it for
approach?
every type you want to compare to.
I'm not sure why. I mean,
you define it equals for, let's say, a core or a point, and you define the equality by a means of how they compare themselves to other points or other superclasses. That I got from your statement. You have to define how you compare yourselves to different classes. Is that what?
no. The idea was that the equals method is not some object taking method, but your color point has one equality method, and it only ever takes another color point.
Yeah,
and
it's specific for the. It's specific for
one
the
equality method that only ever takes a point. So you
it's
only
not-
ever have one
That's
equals method.
problem with that is that's like, if it's the same equals method, you can't overwrite it that way because it's the opposite. Like that's covariant parameter types, because you've made the parameter type in colored point.
Yeah.
It's
Right.
equals method farther down. It needs to be further up if you're going to change it. And Java
You
doesn't
can't
like
write
to
that
do
in Java.
anyway.
I mean, that I think that's looking at it from a very let's say Java perspective. I mean, assume that we are not doing it with methods, but we have this magic equals operator that we're defining in some way.
Well, that's the ecstasy version where he's got the typing system lets him have equals where the two arguments have to be the same type, or you get a type error, the compile time type error. He complains and says, you can't compare point and colored point in the typing system.
We need to make him explain how colored point work.
Right, but to do that, he had to do another
because I'm wondering, like, because he can't tell.
I believe the
type, it might be a point.
culprit, he has the types at runtime. Here, the object is an escape hatch. Defined equals on the object is defining equals on the top type. It doesn't know anything.
Well, I mean, doesn't he do it at compile time? Like
at
look
compile
at the
time,
two
he
types?
decides. Yes, at compile time, he decides the statically known type of the equals of the two sides have to be understood at compile time to be the same type. At runtime, that static type is what is used to do the equals check. Not a virtual
call. Not make any difference. We need to actually see what he says about point and color point, because a static type of a color point could be point in the program.
He can
got the same issue, I think.
No, he's just not a virtual call anymore. At compile time, if the static type happens to be point, you're doing a point equality check statically.
Okay, well, that's symmetric then.
And if you handed him 2 color points,
I see
he
what
would
you're
not
saying.
do a
It's
color
different.
point comparison. He will do a point comparison and ignore your colors.
I see what it is. Okay, yeah, okay, that would work. Okay.
Okay.
I mean, it would work. It just means that
You have to be careful because you don't, you get something
with a
different. It's
point.
not necessarily what you expect.
Yeah, so
You
if
always get the top. You always get the point, no matter how. what
You always get
compare.
the point no matter
No.
what subclassing is
right,
going on
if you
there.
have a if the static type of is point and the static type is color point, it won't compile because they're
It
not
won't compile.
type.
That's correct.
But if this one's been widened to point, I've got 2 points, even though he's got color, it's just ignored. I use the static like equals method to take 2 points.
Yeah.
Otherwise, if they're both colored points, and the heck, they could both be colored points, and I compare them just for they could like be a blue 1,2 and a green 1,2.
Yep.
If the static type is point, it's going to be true.
Yep.
But if their static types are both colored points, it'll be false.
Right.
Which is kind of weird.
Right.
I mean, maybe that's a feature.
That's his feature. Yeah, he
that's a
claims that's a feature. Now he's
That seems fine to me.
he's using it and claims it works. So it might
Well, that
it
would
might
work,
totally
yeah.
work.
Yeah, it would work. It just is that what you want.
Well, that's what I'm saying. It work in terms of a
Maybe
language.
that is what I want. I mean, if
I'd
I'm,
have to
you know,
code it in
all I know is
Anchor
point, maybe what I want.
to decide
Well,
that's what I want. But
I
it
do
might
believe-
be.
Yeah, why not? You have
Yeah.
a green color and a blue color, and you compare it, and you get the color. You don't get. You get the top type. They extend both and take
All right,
extend.
see you, Simon.
Mm.
Get well. Yeah, little TLC. Take care of
Yes.
yourself. All right, bye-bye.
Actually, that might be make. I'm gonna think about it. That actually might make sense because I've got 2 points. That's all I know at this point. I mean, at this place, and I don't know about color, so maybe that's makes more sense.
That's his
Got it.
thesis. You intended to compare points here. They happen to have
Yeah.
subclassing and interesting parts below them, but here you intended to compare
Yeah.
points.
Okay. All right.
How does that interplay with like hash code? Because you want hash code to be consistent with equality.
Yeah,
Oh,
so your
that's what I'm
hash has
saying
to
way.
say, I want the point hash, not the colored point hash.
But
Like if I'm throwing things in that I declare equal, they're both colored points, just like you said, one's 1,2, blue, one's 1,2, red. I intend for them to be equal. I throw them in the same hash table. One of them lands in as a colored point, 1,2 red, 1,2 blue comes along, it hits. I'm going to pull out a 1,2 red, but maybe that's okay because I'm just really trying to say that these two things hit.
So we're just doing away with virtual dispatch then, right? Just whatever the static type is, we're going to use that in these cases, and that seems to clear it up.
Yes. Yes.
Yeah.
I have a very similar issue where I'm trying to do interning of cyclic types. The types all have a unique ID number. I want you to ignore it when I'm doing the equality check in case your equals ignoring your UID. So I guess that's not the same. Never mind. It's not a great example, but there are parts I'm definitely ignoring here. And then the other parts have to be equals. Well, as soon as I go cyclic, I have a different set of problems that have the same thing. I have to recursively be equals around a cycle. And you have to,
I can kind of see the similarity I think you were reaching for, where you have additional data, but you're wanting to project it into a space where you consider fewer things. And that's kind of the same thing we're talking about with color point comparisons against point.
yes. Somebody really was excited to see I have 2 points that are hitting, ignoring color. Yeah. I don't know. Pets versus cats and dogs as another hierarchical example. I'm looking for 2 pets are equal based on their names or what the owner wrote or the owner or something, some other property. And the fact that there are cats and dogs doesn't matter into the test here somehow. All right. Anything else here? Because I'm getting close to declaring victory. No, this was a good discussion. We go find the good discussion of equality and lifetimes and subtyping things and all kinds of lattice things. Fine.
Alan, you want to say something?
Oh, well, I mean, I'm working my way through like so it's like I forget who it is, Bill Myers or something.
Oh, Bertrand Myers.
Bertrand Myers, yeah, he has this book, Object-Oriented Software Construction. You know, the tome.
Yes.
And so he has like this section where he goes through 9 examples of where inheritance is good. And so like I'm working my way through those in order.
Well,
So,
pull out some of those examples next time.
yeah. So this was like number 3. So
Yeah, this is a good screwball example of where you can get it wrong.
yes. So I mean, because I would never have guessed that it wasn't transitive. Like, so
I've seen that before, but I had long forgotten. And as soon as you pulled it out, I'm like, oh, look at that.
all right.
Yep. Totally with you there. It's a good one. All right. Next week. No, not next week. What is next week? Next week, I'll go pull the calendar up. Yeah, let's claim we're skipping till the 30th and see if people show up on December 30th. I'm going to skip the 23rd.
Okay.
All right. How about, happy holidays and all that.
Happy holidays.
Happy holidays. Merry Christmas.
Happy holidays.
Bye-bye.
Bye.
You.
Okay.
Bye.